Welcome back to our series on graphing using transformations. In this video, we're going to talk about reflections. It is probably one of the easiest type of transformation, and there's two types of reflections. So let's go over the first one. The first type has the form y equals, it's your basic function with just a negative sign out front, and it's going to be a reflection, or you're going to take your graph, your basic graph, and reflect it over the x-axis. So let's take a look at an example. We have our basic function, f of x equals x squared. So if I wanted to graph y equals negative x squared, then this negative just means reflect over the x-axis. So any y value that's positive is now negative. Any y value that was negative now goes positive. So 0, 0 still stays 0, 0. But now 1, 1 becomes 1, negative 1. The y value just goes down. 2, 4 now becomes 2, negative 4. 1, 2, 3, 4. 1, 1, I'm sorry, negative 1, 1 is now negative 1, negative 1. And then negative 2, negative 4. So again, everything just gets, think of actually taking this and rotating it over to the other side. And now if I connect the dots, I get my transformed graph. So there's my reflection over the x-axis. Our next type of reflection is y equals f of, and then now instead of the negative being outside the function is now inside the function with the x. It's going to be a reflection over the y-axis. So let's take a look at an example. I actually have to change the function. I'm sorry. So we are now going to do y equals the square root of x. Now my reasoning is that when you reflect it over the y-axis, you end up getting the same function again if you're doing x squared. I'll show you. But let's see what happens with the square root of x. So what I want to do is I want to graph y equals the square root of negative x. So here's my basic function, the square root of x. Now this one's going to be a little bit different because say I plug in 4. I get a y value of 2. Well, what happens when I plug in 4 now? I'll get the square root of negative 4. I can't even do the square root of negative 4. So that actually means that I can't plug in any of these numbers, any of these positive x values, because I'm going to end up square rooting a negative when I plug it in here. So I can't plug in any of these. All right, but what about negative 1? If I plug in the square root, or if I plug in negative 1, I'm going to square root minus and then negative 1, which ends up being the square root of 1, and that's 1. So that means if I plug in negative 1, I get a y value of 1. What happens when I plug in, let's try negative 4. So if I square root minus negative 4, I get the square root of 4, which is 2. So that means when I plug in negative 4, I get 2. In fact, you can actually see what's happening. All of the all your y values are going to end up being over here when you plug in all of these x values. So let me connect the dots and finish the graph. So notice that every point that was over here has now been moved over across the y-axis to the other side. So here is our transformed graph. So before we end on reflections, why couldn't we use f of x equals x squared? We'll take the graph x squared and reflect over the y-axis. That means this point here at 1, 1 goes over here to negative 1, 1. The point here to 4 goes over here to negative 2, 4. And then any point that was over on this side of the graph would end up having to go back to this side. So notice all that's happening is that every point on this side is swapping with every point on that side. And if you were to rotate this around the y-axis, you'd get back the same graph again. We would actually say that that's symmetric about the y-axis, which is something you would learn when you did symmetry with graphs.